Hello students, how are you all? I hope you all good because of God's grace. Let's today we are going to discuss same our matrices chapter number 3 matrix in this previous year board exam questions. Okay, previous year's board exam questions. These are very important before preparing for your main examination. This is about your previous year board exam questions, so we are going to discuss. Okay, so now what I'll do is I'm going to discuss this all. Before going to discuss, let's have a word of prayer, then we can start our class. Close our eyes. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Let's move on to the first question. Alright, this is your first question. Find A if 2A minus 3 minus 1, 1, 2, 0, 5 is equal to another matrix given. So now how to find this is your solution. Minus is there, go to that side, plus, so directly 2A is equal to 1, 5, 3, 2, 0, 1 plus another matrix 3, 1, 0, minus 1, 2, 5. Now normal addition, because these orders are same. So now 2A is equal to 1 plus 3, 4, 5 minus 1, 4, 3 plus 1, 4, 2 plus 2, 4, 0 plus 0, 0, 1 plus 5, 6. Now here 2 is multiplying, go to that side, divide. Divide means divide each element. So now A is equal to 4 upon 2, 4 upon 2, 4 upon 2, 4 upon 2, 0 upon 2, 6 upon 2. So what is your answers? 2 2s are 4, 2 2s are 4, 2 2s are 4, 2 2s are 4, 2 3s are 6. So now 2 zeros are 0. So at last your answer is this, that is 2, 2, 2, 2, 0, 3. So this is about your A matrix. So this is your first question. I hope you all understood this. Alright, the second problem, if A one matrix and B also given, then right, let's move on to the second one. If this, we need to find now A square minus 3B. Our solution is this. Just write A square minus 3B. A square means A write 2 twice, 1 minus 2, 2, 3. And again 1 minus 2, 2, 3. Minus 3 into B. B is here. Minus 5, minus 2, 1, 2. Now just multiply. You know how to multiply. The first row multiplied with first column, you get first element. So now 1 ones are 1, minus 2 into 2, minus 4. So first element completed. Now second element, first row, second column. 1 into minus 2, minus 2, minus 2 into 3, minus 6. Now again same method, second column, second row, first column. 2 ones are 2, plus 3 twos are 6. 2 into minus 2, minus 4, 3 threes are 9. This is your A square minus with 3 table. 3 into minus 5, minus 15. 3 into minus 2, minus 6. 3 ones are 3, 3 twos are 6. Now, minus 3, minus 6, minus 2, minus 8. 8, 9 minus 4, 5. And minus 15, minus 6, 3, 6. Just subtract both each element. Minus 3, minus of minus 15 plus 15. 15 minus 3 is nothing but 12. Next, minus 8 minus of minus 6 is nothing but plus 6. Minus 8 plus 6 is nothing but minus 2. 8 minus 3, 5. 5 minus 6, minus 1. So that is about your answer. So like this you have to solve your second problem. So this is about your problem number 2. You get answer as 12 minus 2, 5 minus 1. Alright, let's move on to the third question. So A given, B given, then find 2A minus B. This again very simple question. So what is I need to find? 2A minus B. 2 into what is A? 2, 4 minus 3, 2. Minus what is B? 1, 3 minus 2, 5. Now multiply with the 2, 2 2s are 4, 2 4s are 8, 2 3s are minus 6, 2 2s are 4, then minus symbol 1, 3 minus 2, 5. Just subtract, normal subtraction. 4 minus 1, 3, 8 minus 3, 5, minus 6, minus of minus 2 is nothing but plus 2. Minus 6 plus 2 is nothing but minus 4. 4 minus 5 is nothing but minus 1. So this is about 2A minus B. Let's move on to the fourth. A given, B given, find AB whole transpose or AB dash. Here AB dash or AB transpose both are same. So what is transpose meaning? Write row as column, column as row. Now let me solve here. This is first find the AB for this solution. First find AB. So A is here 2 minus 4 3 and B is here 2 minus 4 8. So now multiply 2 into 2 4. So you know that first row first column multiplied you get only one single element. 2 2s are 4, minus into minus plus 4 4s are 16, 3 8s are 24. So add this all, what you get? 4, 16 plus 4, 20, 20 plus 4, 20 plus 24, 44. So you got AB is equal to 44, AB dash or AB transpose is equal to 44 only, because whether it is a column or row, you get only one single element is there, means you get that only. So that is about your third and fourth problem. Let's move on to the fifth problem. Alright, let's move on to the next question. If A is equal to 3, 1 minus 1, 2, then prove that A square minus 5A plus 7I2 is equal to 0, where I2 is 2 by 2 matrix given. Again, very simple question. First, given A square minus 5A plus 7I2. This is your LHS. Okay. By using LHS, we need to get our RHS as 0. A square means 3, 1, minus 1, 2, minus 5 into, sorry, A square, right? So if it is A square, multiply this A twice. 3, 1, minus 1, 2, minus 5 into A again. 3, 1, minus 1, 2. Plus 7 into I2 is a 2 by 2 order, means 1, 0, 0, 1. Now multiply first row, first column, you get as first element. 3 3s are 9, 1 into minus 1 minus 1, 3 1s are 3 for second element now. 1 into 2, 2. Next minus 1 3s are minus 3, 2 into minus 1 minus 2, minus 1 into 1 minus 1, 2 into 2 plus 4. Minus 5 table, 5 3s are 15, 5 1s are 5, 5 minus 1s are minus 5, 5 2s are 10, plus 7, 7 1s are 7 zeros are 0, 7 0 0, 7 1s are 7. Now 9 minus 1 is nothing but 8, 5 minus 5, 3, minus 15, 5 minus 5, 10, plus 7 0 0 7. Now we'll simplify that side so that you can understand this clearly. So that is equal to and you simplify 8 minus 15. So when you do 8 minus 15, you get as minus 7. Now 5 minus 5 is nothing but 0. Minus 5 minus of minus 5 means plus 5. Minus 5 plus 5 is nothing but 0. 3 minus 10. So 3 minus 10 is nothing but minus 7. Right? Plus 7 0 0 7. Add these two now. Minus 7 plus 7 0. 0 plus 0 0. 0 plus 0 0. Minus 7 plus 7 0. 0 0 0 is nothing but 0. So you got that 0 matrix. So that is about your RHS. Hence it is proved. Clear? It's very simple, just multiplication and addition. So that is about your fifth. Let's move on to the sixth problem. Alright, let's move on to sixth problem. Construct a 2 by 2 matrix. A is equal to Aj, where elements are given by Aj is equal to minus 5 plus 2j. It is very simple. 2 by 2 matrix they say. So what is our general 2 by 2 matrix? A 2 by 2 matrix, that means A11, A12, A21, A22. So these values we have to find. So now A11, A12, A21, A22. Just write, substitute the values. I as 1, J as 1. So minus 5 into 1 plus 2 into 1. Next minus 5 into 1 plus 2 into 2. Next minus 5 into 2 plus 2 into 1. Next minus 5 into 2 plus 2 into 2. Simplify. Minus 5 plus 2, minus 5 plus 4, minus 10 plus 2, minus 10 plus 4. So let me simplify. Minus 3, minus 1, minus 8, minus 10 plus 4, minus 6. You got all the elements, just substitute here. That is your required answer. What are those? Minus 3, minus 1, minus 8, minus 6. That's all about your sixth question. So let's move on to the seventh problem. Alright, let's move on to the seventh and eighth problem. Where they give 2a plus b is equal to this and b value also given, then just substitute that. A plus b, go to that side, minus b. So directly I am writing here 2a is equal to 3 minus 1, 2, 4 minus b. And here 3 minus 1, 2, 4. What is b here? B is they already given minus 1, minus 5, 0, 2. So just subtract it, what you get now? 3 minus of minus 1 plus 1. 3 plus 1 is nothing but 4. So minus 1 minus into minus plus 5. So 5 minus 1 is nothing but again 4. 2 plus 0, 2 minus 0, 2. Next 4 minus 2 is nothing but 2. So this is about, you got 2a. Now here 2 common in this. So 2a is equal to here 2 common. 2 2s are 4, 2 2s are 4, 2 1s are 2 1s are. So 2 get cancelled. At last this implies a is equal to 2 2 1 1. This is about your answer for your problem number 7. Okay, let's move on to the problem number 8 now. So that is A they given, B they given, and we need to find AB. So here first, always remember, if you want to multiply, first check the order. So here 1 row, 3 columns. Here 3, 1, 2, 3. 3 rows, 1 column. So now here these two should be equal. Already it is equal. So number of columns in first matrix is equal to number of rows in second matrix. These both are equal, then we can find. So now solution, AB is equal to 1, 2, 3 and B is 1, 2, 3. You know, row is multiplied with the column, you get one element only here. So then 1 1s are 1 plus 2 2s are 4 plus 3 3s are 9. 9 plus 1, 10, 10 plus 4, 14. So 14 is your answer of AB. So this is about your problem number 8. So I hope you are understood these two problems. Let's move on to the ninth problem. Alright, let's move on to 10th problem. A is given and find a square minus 5a plus 6i. Where I is 3 by 3 matrix. Again simple question. So first given one, right, a square minus 5a plus 6i. So a square means 2 0 1 2 1 3, and the one it is 1 minus 1 0. Again a 2 0 1 2 1 3 1 minus 1 0, then minus 5 into a, again a 2 0 1 2 1 3 1 minus 1 0, plus 6i. 6 into I is nothing but 1 0 0 0 1 0 0 0 1. Okay, so after this what we need to do? So after this, just the first row multiply with first column for first element. So I'll multiply here 2 into 2 4 plus 0 into 2 0 plus 1 into 1 1. So same method now, first row second column for second element, 2 into 0 0, 0 into 1 0, 1 into minus 1 minus 1. Next same method, third row also, 2 into 1 2, 0 into 3 0, 1 into 0 0. Same method next also, 2 into 2, that means second row first column, 2 2s are 4 plus 1 2s are 2 plus 3 1s are 3. Next 2 zeros are 0, 1 1s are 1, 3 into minus 1 minus 3. Next 2 into 1 2, 1 into 3 3, 3 into 0 0. Next last and final one, that is 1 third row first column, 1 into 2 2, minus 1 into 2 minus 2, 0 into 1 0. Next 1 into 0 0, minus 1 into 1 minus 1, 0 into minus 1 0. Next 1 into 1 1, minus 1 into 3 minus 3, 0 into 0 0. Minus 5 table multiply, 5 2s are 10, 5 0 0, 5 1s are 5, 5 2s are 10, 5 1s are 5, 5 3s are 15, 5 1s are 5, 5 into minus 1 minus 5, 5 zeros are 0. Then plus this 6 1s are 6 0 0, 6 0 0, 6 0 0, 6 1s are 6, 6 0 0, 6 zeros are 0, 6 0 0, 6 1s are 6. Very simple. Now 4 plus 1 5, 0 0 minus 1 means minus 1 2, 4 plus 2 6, 6 plus 3 9, minus 3 plus 1 minus 2, 3 plus 2 5, minus 2 and plus 2 it becomes as 0. This is minus 1. Your minus 3 plus 1 means minus 2. Correct. Next minus 10 0 5, 10 5 15, 5 minus 5 0, plus 6 0 0 0 6 0 0 0 6. Now first subtract these two. 5 minus 10, that is nothing but minus 5. Minus 1 minus 0 is nothing but minus 1. 2 minus 5 is nothing but minus 3. Next 9 minus 10 is nothing but minus 1. Minus 2 minus 5 is nothing but minus 7. Next 5 minus 15. 5 minus 15 is nothing but minus 10. Next 0 minus 5 is nothing but minus 5. Minus 1 minus into minus plus 5. 5 minus 1 is nothing but 4. Now minus 2 minus 0 is nothing but minus 2. But plus 6000060. Add both and write the answer. Let me write here answer. I'll rub this part and I'll write here. Okay. So here itself I'm going to write now our answer. Because you all written this part, I hope. If not, you pause the video and find the answer. So next, here it is. This is your answer. So that is equal to, that means a square minus 5a plus 6i is equal to minus 5 plus 6 is nothing but 1. Minus 1 plus 0, minus 1. Minus 3 plus 0, minus 3. Minus 1 plus 0, minus 1. Minus 7 plus 6 is nothing but minus 1. Minus 10 plus 0, minus 10. And then minus 5 plus 0, minus 5. 4 plus 0, 4. Minus 2 plus 6 is nothing but 4. So at last you get your answer as 1 minus 1. You get answer as 1 minus 1 minus 3 minus 1 minus 1 minus 10 minus 5 4 4. So in this way you have to solve your problem number 10. Okay. So I done, I was done everything in simplest form. But what if you want to do a square separately, 5a separately, 6a separately, separately multiply and add all. So that also you can do. Whichever you feel easy, that you can go for it. That is about your problem number 10. So let's move on to the problem number 11. Alright, let's move on to the 11th and 12th problems. If a is equal to cos alpha, sin alpha, minus sin alpha, cos alpha, then find a square. It is very simple, just you can observe. A square is equal to, you know that, a into a, that is nothing but cos alpha, sin alpha, minus sin alpha, cos alpha. Same method, one more time. Cos alpha, sin alpha, minus sin alpha, cos alpha. Because you observe here this a into a, because a square. So a written, the first row, first column, you get first element. Now cos alpha into cos alpha, cos square alpha. Sin alpha into sin, minus sin alpha, minus sin square alpha. Right. So next one here, cos alpha, first one into second row. Sorry, first row into second column. Cos alpha into sin alpha. So right here sin alpha, cos alpha. Next, sin alpha into cos alpha. So plus sin alpha into cos alpha. Next, second one, minus sin alpha into cos alpha, right? Minus sin alpha, cos alpha. Next, cos alpha into minus sin, again minus sin alpha, cos alpha. Next, minus sin alpha into sin alpha, minus sin square alpha. Plus cos alpha into cos alpha, cos square alpha. So now check carefully. Cos square alpha minus sin square alpha is nothing but cos 2 alpha. And here, see, sin alpha, cos alpha, sin alpha, cos alpha. 2 sin alpha, cos alpha. Next here, minus common. Then again 2 sin alpha, cos alpha. Cos square alpha minus sin square alpha, cos 2 alpha. Now, you already know one formula. 2 sin alpha, cos alpha is nothing but sin 2 alpha. So right here it is cos 2 alpha, sin 2 alpha, minus sin 2 alpha, and then cos 2 alpha. Like this you have to solve your 11th problem. Let's move on to the 12th one. A given, then find a plus a dash. Here a dash is nothing but what? A transpose. Okay, a transpose, another name it is a dash. Okay, so let me write here a plus a dash. Directly I am writing. A is here what? 1 5 6 7 plus a dash means, so I already said row as column, column as row. So 1 5 is row, write as column. 6 7 as row, write as column. 6 7 Add both. 1 plus 1, 2. 5 plus 6, 11. 6 plus 5, 11. 7 plus 7, 14. So at last your answer is 2, 11, 11, 14. This is about your problem number 12. So I hope so you all understood. If you are not understand, comment on YouTube comment section so that I can help you. Alright, this is your 13th question. If a is equal to 0 minus tan alpha upon 2 tan alpha upon 2 0, then I is equal to 1 0 0 1. Then prove that I plus a is equal to I minus a cos alpha minus sin alpha cos alpha. This question as it is we got, but instead of alpha we got as x in exercise number 3.2 12th problem. So as it is same answer, as it is same answer, instead of this alpha there x is there, wherever x is there just substitute alpha in that place, you are going to get your answer. So that is homework for you. You just concentrate, refer your exercise number 3.2 12th problem. Okay, so this was explained in the last video. Okay, so that is about your 13th one and it is homework for you all. So now let's move on to the 14th problem. Alright, next question. If A given and B given, then find AB. First rule for multiplication is first matrix rule columns, number of columns is equal to second matrix number of rows. Let me check now. Here 3 rows 2 columns and here 2 rows 3 columns. So here 2 2 both are same, so that's the reason we can multiply. So now AB is equal to A is here 2 1 3 2 minus 1 1 and your B is 1 0 1 minus 1 2 1. First row, first column. So for first element. So what is your resultant order? 3 by 3. So now first row, first column means 2 ones are 2. 1 into minus 1, minus 1. Next 2 zeros are 0. 1 twos are 2. 2 ones are 1. Now see, for first element, first row, first column multiply. For second element, first row, second column. For third element, first row, third column. So now 2 ones are 2 plus 1 ones are 1. Now again second row. 3 ones are 3. 2 minus 1s are minus 2. 3 zeros are 0. 2 into 2, 4. Next 3 into 1, 3. 2 ones are 2. Same method, minus 1 into 1, minus 1. 1 into minus 1, again minus 1. Minus 1 into 0, 0. 1 into 2, 2. Minus 1 into 1, minus 1. 1 into 1, 1. So at last we get what we get our answer. 1, 2, 3. That is 3 minus 2 is nothing but 1, 4, 5, minus 2, 2, 0. So at last your answer is 1, 2, 3, 1, 4, 5, minus 2, 2, 0. That much simple. So this is about your 14th problem. Let's move on to the 15th one. Alright, this is your next question. So here construct a matrix of order 3 by 2 where elements were given by Aij is equal to 2i minus j. So first for this solution, let A is, that is 3 by 2 matrix means, so 3 by 2. So rows are 3, columns are 2. So 3 rows and columns are 2 you have to write, that is A11, A12. A21, A22, A31, A32. Check now 1, 2, 3. 3 rows, 2 columns. So now these values if you are able to find, then completed your answer. So now Aij already given, then find A11, A12, A21, A22, A31, A32. So very simple, this all. 2 into I, 2 into 1 minus 1, it is 2 into 1 minus 2, and next one 2 into 2 minus 1, next 2 into 2 minus 2, then 2 into 3 minus 1, because here I and j values I am substituting, 2 into 3 minus 2. So now you can multiply 2 1s are 2, 2 minus 1 is nothing but 1, and 2 minus 2 is nothing but 0, 4 minus 1 3, 4 minus 2 2, 6 minus 1 5, 6 minus 2 4. So at last your answer is 103,254. So this is about your answer. So at last what you got here? So you got answer as 103254. So this is about your problem number 15, and let's move on to the last previous board exam problem for this matrix chapter. Alright, let's move on to next. If f of x is equal to cos x minus sin x 0 sin x cos x 0 0 0 1, then prove that f of x f of y is equal to capital F of x plus y. This is the given. So but this already we solved in exercise number 3.2 problem number 6 as it is only. But what is difference between this and that? It is there they given f of a f of b is equal to f of a plus b. This is the given, but instead of a we need to write x, instead of b we need to write y. Only that simple change if you are able to do, you are able to solve your problem number 16. So very simple function they given as it is, but they were written in that question. It is given as f of a, f of b is equal to f of a plus b. But now you need to apply in the a plus x, b plus y, or just replace in the place of, in the solution of problem number 6, a plus x, b plus y. Then you get your answer. That is about your problem number 16. And if anyone have any doubts, kindly comment on YouTube comment section so that I can help you all. So I hope so you all understood. This is about your previous board exam questions, and let's so this is about all. Just practice it. After that I'm going to conduct exam. And second one, so next chapter we are going to discuss after this completion of test. Okay, so that is your determinants. So may God bless you all.